Hello everybody. So you're used to the idea of distance versus time graphs, but today we're going to start velocity versus time graphs, otherwise called VT graphs. All right, so first point of emphasis is that you should remember with a distance time graph, how did we measure the velocity? Was the slope. The slope was equal to the velocity on a distance time graph. So if I asked you to calculate the velocity when you had a distance time graph, you would just take the slope. But now what's different with a velocity versus time graph, I'll draw some new axes with a V on the y-axis instead of a D on the y-axis. There's a V there. The slope is no longer the velocity. You get the velocity straight from the y-axis. You could just read it off there, 10 meters per second or lower, like 5 meters per second. The velocity is just right there on the y-axis. All right, so even in that way, it's a little easier than a distance time graph. All right, so there are 4 graphs you need to know on a velocity versus time graph. Let's move that way. The first one you need to know is constant velocity. And the next one you're going to need to know is stopped. I'm going to need to get me a pen. That's okay. Stopped. You can make a little chart like this. And the next 2 you can anticipate are going to be speeding up and slowing down. So you could create some blank spots where you draw axes with V and T under each title. And you need to know the shape of these 4 motions. The velocity we're going to deal with is always moving forward, all right? Always moving forward. So it's always going to be a positive velocity. Now, constant velocity, you're used to it being a straight line like this, all right? But that was on a distance time graph. For a velocity time graph, constant velocity looks like a flat line. Because the velocity is on the y-axis, a flat line will mean that the velocity is not going up, like getting faster, and the velocity is not going down. That would be like getting slower, all right? If it's a flat line, it means the velocity is staying the same. All right? Now for stopped, that means it's a constant speed too, a constant speed of 0. So what that is if you have a flat line, but it's down here, okay? Down here where the velocity is 0, right there, all right? So if you get a line like that on the time axis, that means the velocity is 0, that means you're stopped. But it's still a flat line because your velocity is staying the same number of 0. Speeding up means that your velocity is increasing. So it kind of looks like this. The line goes up. And slowing down means your velocity is decreasing. Meaning you start fast, which means up here, and the velocity is very low by the end. All right, so those are the 4 shapes you need to know for your velocity time graph. Constant speed. So when you have a flat line at the bottom, it's when you're stopped. Speeding up, the velocity goes up. Slowing down, velocity goes down, looks like a decline. Actually a little easier than distance time graphs, in a way. Just don't mix them up. All right, what does the slope mean? That's the last thing we want to look at. What does the slope measure on a VT graph? So write that down on a VT graph. What does the slope measure on a VT graph? So let's draw some axes again here, V and T. And we could draw speeding up as an example, like that. Velocity is going up. So what does the slope measure? The slope is always rise over run. Now, instead of rise, that has to do with the y-axis. So that means the rise is when the velocity goes up there. So it's a change in velocity, delta V, all right? And the run over this way is going to be like the x-axis. It's going to be time. So it used to be where the rise on a distance time graph was distance. But now the rise is the change in velocity. How much does your velocity go up? But the run is still the time, just like a distance time graph. What does delta V over t give you? When you divide delta V by t, that's a change in velocity in an amount of time. That calculates the acceleration, A. So the slope, or the rise or run of a VT graph is the acceleration. Now, this is for a VT graph. The slope gets us acceleration, all right? For a distance time graph, the slope got us velocity. Don't confuse the two, okay? Now, let's go back and look at the slopes here. What's the slope of, for these four graphs? Let's look at the slope. The slope here is what? For the flat line, that's always a slope of 0. And that's why the acceleration is 0. Again, if you're stopped, what's the slope? Well, it's not going up or down. Again, it's a slope of 0. And that's why when you stay stopped, your acceleration is 0. There's no change in your speed when you stay at rest. And when you're speeding up, what's the slope of that line? Oh, what kind of number is that? That is a, going up, it's a positive slope. So that means when you speed up, what kind of acceleration do you have? Also a positive. The slope, when it's positive, gives us a positive acceleration. And finally, with slowing down, the slope, oh, looks like it's going down now. The slope is a negative. So that means our acceleration is also a negative, which makes sense because we are slowing down.